Hello developers, let's start developing. It's December of 2025 and the 1st of December, so that means that we're gonna take on the first task from this year's Advent of Code. Because of reasons, this year we're only gonna have 12 tasks, which means that might be harder. But anyway, elves have discovered project management. Good for them. And now we need to open some safe. That's the story. The safe starts at position, there is a dial that starts at position 50 and we need to count the number of times the dial is left pointing at 0 after any rotation in any sequence, which means that in our code we need to take care of the position of the dial. But anyway, let's start as always by parsing the input. So the input is in this format. There is an L and there is a number, which means that we're gonna need to do some rotating. So what, as always, we're gonna start with some types. So type, it's not input, this is a command or instruction or something like that. Yeah, an instruction, we can say. Instruction is a type that has a direction, which can be either be a literal R, which means we're going right. So right goes toward higher numbers, which mean 1, 2, 3, 4. Left goes towards lower numbers, so 4, 3, 1, 0, 99. Since we're on a loop. And the number of steps. So we have a list of instructions. Basically our input is not going to be an array of strings, it's going to be an array of instructions. And we're actually giving out a number. The input will be an array of instructions and yeah, the process input should return not a string array, but an array of instructions. Yeah. Instruction array. Yeah. So at the very least our code will compile once we process the lines. So for off, actually we can map all these lines, lines.map for each line. We can, I'm gonna use Copilot heavily, but I will always check what it gives me and reason through it, because that's the proper way. So we can take the first character of the line and as an error R or L. It's not always type safe because we are kind of guaranteed that there will be an L or an R at the first position, but we cannot enforce that guarantee. Anyway, the rest of it will be an integer and we parse that and then we can return those instructions. Return the instructions, not the lines. So now everything is okay and we can run it with a debug now. Let's see it. How do we run it with a debug? I have no idea. Yeah, start debug. So let's do that. npm run start debug the first day of 2025. Yay, we are parsing. So LLR 68 30 48. Let's see if we are correct. 68 30 48. Yep, that's great. So now we need to actually do the processing, which is easier because we have the instruction format, so we don't need to do any of those things. We don't really care about the debugging right now, so let's leave that. So what we can do, for each instruction we can have a current position, and the current position is at 50. And now we can just have another counter or the result actually, which initially is gonna be 0, and now we can say for each instruction of the input, yes, something like this. If we're going on in the right way, if we're going to the right, then we increase it, otherwise we decrease it, and that's it. Only if position is bigger than or equal to 100, we're just gonna remove 100. Similarly here, if the position is bigger than less than 0, so minus 1 becomes 99 actually. So now we can say if position is 0, then we increment the result. So for our initial value, we're gonna need to return basically 3. And why not? Let's just add the current position over here. Let's start with this. Let's see, we have the input and the current position goes 82, 52, 0, 95, 55, 0. Let's see. 82, 52, 0, 95, 55, 0, 99, 0, 14, 32. Seems okay. Result part 1 is 3. So now I will just remove this console log, we don't need it at the moment, and let it run on the proper input, which is a bit bigger. Yay, we have a lot of lines. Let's see. Oh, we have 4,500 lines. So let's run it. And it says the result part 1 is 284. Let's see if this is the correct answer and if we get a star from Santa. No, we didn't, which means now we get to debug our code. So what are we gonna do first? Well, let's return the console log. Let's see how the current position moves. There is a lot of movement here. Well, let's start it this way, we don't need the input. And it seems we have some zeros. And then we have some negative numbers. And some thousands and everything. Okay, this could be a problem. So one thing that people have told me is that, oh, you make sometimes intentional bugs to show up something. No, I don't make them, they just happen. But I'm not worried about them too much because, well, because I know how to analyze it and I know how to do it. So now I think I know what we need to do, because we need to constrain the result between 0 and 99. So we can do something like position is position modulo 100. And I don't think that this is gonna work. Now this is intentional because I think we're gonna mess things up. We're gonna get another result which is much higher, but you can see we're also getting a lot of negative numbers. Why? Because in JavaScript, a modulo of a negative number is a negative number. Let's take a look at that. So that means minus 1 modulo 100 is gonna be minus 1. So let's create a method. Let's call it trim, that we can, or to lock, yeah, where we're gonna take a number, and so the initial version will be just modulo 100, and we want to lock, let's do something like this, we want some values, so 1, 100, 101, minus 1, minus 99, minus 300, So we have some values, and let's map all of it with toLock. So we're just gonna do some testing until we get the results with what we want. So we can see that, okay, we managed to see something that exists actually in JavaScript that doesn't exist in too many languages. For -300, we got the number -0. That is a thing that exists in JavaScript. You can see that for the positive numbers we got okay values, but for the negative we didn't. So let's change this up a bit. So after this happens, we are guaranteed to have a number that's between -99, since we're only working with integers, up to +99. Which means that if I take and lift this by 100, I'm guaranteed to get a positive number. Yep, so I'm getting a positive number, and now on this positive number I can do the regular modulo operation, which means that now I get the correct position on the lock. Okay, let's take this thing that we developed here and let's plop it in the code to lock. And yeah, now since we're in TypeScript, now we just have to say that this is a number, so everything is fine and dandy. So now we're gonna calculate the position, and instead of just using the modulo, we're gonna use the complicated module. So let's rerun this. Let's see. The numbers look okay, and weirdly the answer seems to be unchanged, 1141. That's kind of weird, but one way to find out. Return to day one. Let's see if 1141 is the right answer, and we have a gold star. Let's just take a look at it for a second, and then we can continue with part 2. I have no idea what part 2 is, so let's read it a bit. So our door won't open, and we have another thing that we need to count. We actually need to count each time the dial points at 0. So we are starting at 50, we are rotating left 68, so we're going past the 0, which means we need to add 1. So each time we're going past 0, we need to add 1. So the code for our second counting is gonna be a bit more complicated. The general format will stay exactly the same. We are starting at position 50, we have our inputs, we move through each of them, and then we're gonna need to do something like this. So we're going right. How do we know if we're going past 0? Well, if the current position, actually I will define another variable that will actually start with instruction.steps, and that we're gonna call clicks. That is the number of clicks that we have yet to do. And now we can say, while we can do some math here, but I'm gonna choose up a straight up simulation. So we're going right, so we're going to bigger numbers, which means that while there are clicks, we need to click. Oh yeah, let's go with a simple and stupid and full simulation. Well, clicks is bigger than 0, position is that we, yeah, this will work. So what does this code do? This code will basically do the clicks one by one. Click, 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 which means that we're going to waste a lot of power going from, I don't know, 1000 times from 7 to get back at 7. And we're going to pass 10, 0 a few times. But we're going from 10 to 90, we're going to do 80 clicks and do nothing here. So, but that approach will actually work. So now, while clicks is bigger than 0, we're going the other direction. We're transferring the modulo. If it's 0, result is bigger than 0, and reduce the number of clicks. We don't really need this here, and we don't really need this here because we're taking care of that thing above in the code. That, yeah, let's zoom this code a bit so you can see it better on YouTube. And return the result. Let's move to the small input and see whether we get 6. Result for part 2 is 6. So we are doing a straight up simulation that wastes a lot of resources because I think that we will have some weirdly large things. Yeah, 802, 426. We can do some kind of input analysis to see. And what I'm looking for now is some ridiculous numbers. Let's actually check that. So we're gonna need to have a test. So inside our input, actually inside our, yeah, we can actually use the input here, and we can not only log the console but input dot max. Do I have a max method? Yep, that is a custom max method. I have no idea. Yeah, max find, min find. Yeah, we can use this, that's enough, which is the maximum number of steps that we want to do. And if I'm not mistaken, to run that we need to do test. So npm test 1. Oh, the maximum is 999, and I was afraid that we might get something that is something like 2 billion. So we're not doing that. For 999, even times 5,000, that is a few million clicks that we were gonna need to do. So let's get clicking. npm start 1 for the biggest input, and it says we're going past the 0 6,634 times. But you can see for the running time for the part 1 is 1 millisecond, which is basically very fast, but it's 14 milliseconds for the second part because of all the clicking. Let's see if we get the correct answer. Yes, we did, with a terribly inefficient code. Eventually, we might do some proper math, because it's obvious if we rotate 200 times, for example, we're gonna go past 0 twice. If we run 500 times, we're gonna go past 0 5 times. So we can just count the numbers of that, but not just simulate them. But this code works, this code is reasonably fast, so that's why I'm gonna leave it at that. So that's it for now. Keep developing. Don't forget to click like, subscribe, and everything, and see you tomorrow.